In this video, we'll explore the graph of a function. Now, when we want to determine whether a graph is a function, we use the vertical line test. And what we do is we run vertical lines through the graph to verify that a vertical line does not touch the graph at more than one point anywhere on that graph. So here are three different graphs that I have, and I'm going to run vertical lines through them to make sure that they are functions. However, with this first one, as I run the vertical line through this graph, I end up hitting this parabola at two different places all along it. So since I'm hitting at two places, that cannot be a function. Here, as I run my vertical line through the graph, through this hyperbola, I'm continuing to hit that graph at two places again. Since the vertical line hits at two places, that is not a function. And finally, I look at this final graph and I run my vertical line through it. But in this case, each time my vertical line touches a portion of the graph, it hits it exactly one time. So that will be a function. So it can only touch the graph at exactly one time at each location. When I know I have a function, I could be asked to do a couple different things, such as evaluate the function for x, or evaluate it to find with a given x value. I could have to find the domain, the range, and even the x and y intercepts, and you'll be told specifically what you need to find. So here's a graph of a function, and I'm just given the graph. If I want to know the domain, I'd be looking at what's my smallest x value to what is my largest x value. So in this case, I'm going to draw some vertical lines to help me just brace up where everything is, and I can see that I'm going from -9 all the way over to +13. So I can use the formal notation or the interval notation, whichever you feel more comfortable. So in the formal notation, I would say that it's x such that -9 is less than or equal to x is less than or equal to 13. Interval notation would be from -9 to +13. With the range, I'm now looking and saying what's my smallest y value to what is my greatest y value of this graph. So in this case, I'm going from -2 up to 6. So I can say that y such that -2 is less than or equal to y is less than or equal to 6. Or I could just say, using brackets, from -2 to 6. Now say I want to evaluate the function at -5. So that means find the corresponding y when x is -5. And in this case, I see at x equaling -5, it hits right here, which is -5, 3. So this evaluates to be 3. Now say I want to find the y-intercept. That is where's the graph hit the y-axis. And it'll happen only one place if I have a function. At most one place. In this case, it hits at 0, -2. Now maybe I'm asked also to find the x values for a specific function. So if I know that the function of x equals 1, I'd be looking and saying, well, where is it that my y values are 1? So I'm just going to draw a line and I can look for all those. And it happens at three different places. When x is -2, when x is 4, and when x is 13. Now I can ask to do this with an equation as well. So say I have f of x equals x squared minus 9. My domain, I would always look for limiting factors. Do I have an even index radical, or do I have anything in the denominator? In this case, neither of those exist, so I know that my solution is all real numbers for the domain. For my range, I need to graph that equation to be able to see really where does it exist. And in this case, when I look at this graph, I'm looking at what's my lowest y value to what is my highest y value. And what I can see is that my y value bottoms out at -9, but then it goes on forever, i.e. to infinity. So I can either write this in the formal notation or interval notation. So I could say that it's y greater than or equal to -9, or I could say that from bracket -9 going all the way to infinity using the parenthesis. Either method is fine. If I want to find the x-intercept, I could use the graph, or I could formally work it out. And I know that my x-intercept, f of x, is 0. So 0 equals x squared minus 9. I'm going to move the 9 over, take the square root, and remember that's plus or minus when I take the square root, so that my two X-intercepts will be -3, 0, and 3, 0. And I could also look at the graph and I could see that quite clearly on this specific graph as well. Lastly, maybe I want to find the f of -8. That means I'm going to plug a -8 in for x and simplify. So -8 squared is 64. 64 minus 9 is 55.